In this tutorial, we're going to do a quick review over inequalities. In the first inequality, we have x is greater than negative 3. X is a number that's got to be larger than negative 3. On a number line, we represent that with an open circle on negative 3 because we want values that are larger than negative 3 but don't actually include negative 3. And then we're going to think about, well, which direction would this arrow go? It would go to the right. Negative 2, negative 1, and the positive numbers would all be greater than negative 3. Keep in mind, when we're saying greater than negative 3, we're also including numbers like negative 2.999 and all the decimals in between here. In the next one, we have x is less than or equal to 0. So because x is a number that is less than 0 but also equal to, see that little line underneath there? That means we're going to put a closed circle, which means that's going to include 0. And then we think about, well, what are the numbers that are less than 0? And then we're going to make our arrow go to the left because that represents the numbers that are less than 0. Now let's go ahead and solve an inequality here. I want to solve 2x minus 1 is less than negative 7. To do that, I'm going to start off by adding 1 to both sides. So this works out just like our equations. We don't do anything differently here in this case. And then I'm going to get a negative 6, and then I'm going to divide both sides by 2, like so. So I'm left with x is less than negative 3. Now I want to graph this solution. So here I have my number line. I'm just going to make a mark here, approximately negative 3. And because x is less than negative 3, I'm going to put an open circle because it's not actually equal to, and my arrow is going to go to the left for all values less than negative 3, like negative 4, negative 5, and so forth. In the next example here, we want to get our variables on one side of the inequality. Now, just like the equations, it doesn't matter which side you move it on. Again, I like to move it to the left most of the time. So I'm going to start off by subtracting 6x from both sides. That's going to leave me with negative 2x plus 3 is less than or equal to, okay, we have a minus 5 here, and it's useful to think about subtraction as being an operation that doesn't really exist. What really exists is what's known as the additive inverse. That means adding the opposite sign. So because this was just a minus 5, it's like saying plus negative 5. So we're left with a negative 5 by itself on the right side of the inequality. And now we're going to continue to treat this like any other equation. We'll subtract 3 from both sides. So negative 2x is less than or equal to negative 8. And then I'm going to divide both sides by negative 2. Now this step here is really important because I'm dividing by a negative number. And whenever you divide or multiply by a negative number, you're going to flip that inequality sign around. So you want to make special note of that. When you multiply or divide by a negative number, so here the 2's cancel, but now this is going to become greater than or equal to a positive 4. So that's going to be my solution. So just one thing you need to be careful of. So when I graph this, I'm going to have a closed circle on positive 4, but my arrow is going to go to the right because we flipped the sign and now it says all the solutions have to be larger than 4 or equal to. So that concludes this tutorial.